Daniel van Strien has worked on this cool example, or very applicable and very approachable example of how to use distilabel, which might be a competitor to DSPI or an alternative to, how to use that to create a haiku-dpo dataset from scratch, because normally, the LLM and large language models have some difficulties with that. But he's going to present about his work and all of the things that he's been doing at Hugging Face in general, and then also about how he used the distilabel to generate this haiku-dpo dataset. And then after that, I will give a brief overview of also the stuff that we've recently been doing together with Hugging Face for the prompt collective community effort that we've launched for actually rating prompts from different data sets, both human and synthetically generated data. And then also delve back a bit on how to use distilabel to actually create preference data from high quality prompts. But now I'll give the mic over to Daniel.
Thank you, David. Let me just share my screen. Okay. Can you see that okay?
Yeah, perfect.
Perfect.
Okay, so I'm going to talk about this project that David mentioned about haikus. So this is a personal project that I've been working on and off for a month or two. And it was really a project partly for me to learn a little bit more about this topic, particularly around synthetic dataset generation, but also how language models could be more aligned to particular desired outputs. And I'll talk a little bit more about what I mean when I get to that part. But before I talk about that project, I wanted to talk very quickly about Hugging Face and datasets in general, and just give an overview of some of the things that we're working on to try and make the Hugging Face hub more interesting for datasets and more useful for people creating datasets. I think probably most of you will be familiar with the Hugging Face hub. If you're not, then I can briefly describe it as like GitHub, but instead of people sharing code repositories, they can upload machine learning models or data sets or machine learning applications that other people can then build on top of. So the goal with the hub is to democratize machine learning by making state-of-the-art models more accessible, but also very importantly, I think something that will probably resonate with a lot of you here, is to try and make sure that there's high quality data available, and that high quality data is available across different domains and different tasks, which I think is a work in progress, but something that's hopefully improving over time. To illustrate that, actually, at the moment, this is the number from yesterday of how many models and data sets that are on the hub. And as you can see, there's a lot more models and data sets at the moment, but the amount of data sets is growing quite rapidly. And we're quite keen to make sure that people are sharing data sets as well, because I think in the open source community, sometimes people sharing models is more highly valued than sharing data sets, but actually high quality data sets can enable a lot of really impactful work and can often have a very long-term kind of resonance and impact. So I think it's very important that as a community, we get better encouraging people and rewarding people to share data sets. So one of the things we've seen a lot of this year is synthetic data becoming more and more of a topic. So this is a paper actually from last year called Textbooks Are All You Need. And what this paper tried to do is to train a fairly small language model, but train it on a very well-curated corpus. But that corpus was not well-curated through humans going out and finding material and then assembling it, but rather constructing the data that people thought would be useful for the model. In this case, trying to create synthetic book data and then trying to present that in a way that would be useful for a large language model to learn desired properties. And we've seen in the past couple of months a lot more synthetic data on the hub. So one of the things we've done to try and support that is to add this synthetic data tag, which will hopefully make it easier for people to find synthetic data when they want it, but also make it easier for people to know whether a data set is synthetic when they might not want synthetic data to be included in their training data. And another feature that probably if you've been on the hub at all, you'll be familiar with is this dataset server, which gives you a preview of the dataset and gives you some quite nice insights already about some of the properties of the dataset. So you'll often see things like the distribution for label values, the length of text fields and things like that. So I don't think this is a replacement for very closely looking at the data, but I think it can be very useful for giving you a quick sense before you download a data set, what's in it and whether it's going to be potentially useful for you or not. And another thing that I've been doing a little bit of work on is trying to improve the metadata for datasets on the hub, which I would say is a kind of mixed story. So we see a lot of people sharing very cool datasets, but sometimes that comes with like very little documentation, which makes it very hard for other people to find or know how to use that dataset. And trying to make that process of adding documentation easier is one thing that I think will be quite impactful. And a particular area that I've tried to focus on is language metadata. So I mentioned a little while ago that we're interested in the diversity of languages on the hub in terms of what kind of data sets are on the hub. And at the moment, as you can probably guess, the language is predominantly English. There are other languages that feature very heavily. But we also found that there were a lot of data sets on the hub in languages that are not well represented that didn't make that clear. So we created this librarian bot that basically checks for new data sets every day. And if it doesn't have language metadata, and it seems like it should, it will try and predict the language for that, and then make a pull request to add that language data. So it's definitely a work in progress, but hopefully over time we'll see better information about language for datasets on the hub. And the other thing that I wanted to mention, which I think is particularly relevant for Argilla and distilabel, is that we're trying to make sure that people are able to use the Hugging Face hub as a platform for data sets. So the hub has had, over the past couple of years, a lot of machine learning model frameworks and libraries integrated. So it's not just a transformers library where you can push and pull models from the hub, but also Spacey and a bunch of other libraries where people can very easily share model weights for those libraries. And we want to support something similar for datasets on the hub. And I would say for this, Argilla and distilabel have really pushed that feature the furthest, but that's something that we're very keen to see more of as we go forward. So I'll switch to talking about this haiku-dpo project now. As I mentioned, it was very much a personal project for me to try and get to grips with some of these topics. In general, I try and read papers that come out, and I was going to wear a DPO for a while, but I wanted to really have a project that I could go through and continue to play with to try and get my head around some of these topics. So this is where this project is at the moment, and I think I've picked up some better intuitions, but I'm definitely not an expert. This is a learning project for me too. But I guess the starting question for me was really about whether we can make language model match aesthetic preferences more closely. And what I mean by this is I think often people will talk about aligning language models, so they'll talk about alignment. And they'll often talk about it as a kind of singular thing, that this model is well aligned. And I always find that a little bit jarring, and it's probably my kind of humanities background that's still in the back of my head. But I think there's a lot of different ways in which you could try and align a language model. And the other thing that I've been seeing quite a lot of, and particularly in some of the kind of open source communities who are starting to adopt language models as a tool, there's a lot of interest in making a language model that's very customized for a particular task or for a particular domain. And one way in which I think that could be interesting is to see if a language model can be more closely aligned with an individual person's aesthetic preferences. So does it produce text that they like in some kind of slightly vague, ill-defined way, but that they can probably not quantify, but they can say, I prefer this text to this text. And I originally had a kind of slightly different starting point for this project, where I was thinking about trying to generate descriptions for science fiction, so a paragraph describing some part of a science fiction novel. But that quite quickly it became a bit unwieldy and quite hard to manage, and particularly because it's then becomes very difficult to actually create these preference rankings, which I'll get back to in a little while. So for a few reasons, I ended up landing on the idea of instead focusing on haiku. So probably most of you are familiar with haiku as a form of poetry, but it originates from Japan, and probably the translations into English are slightly clunky in a way, but the kind of rough form that they usually take when they're translated or composed in English is to have this 3-line structure, where on the first line you have 5 syllables, the second line you have 7 syllables, and then the last line you have 5 syllables. And this kind of feature ends up being quite interesting later on when we're trying to think about how to create this preference data. So as I mentioned, the goal of this project was to learn more about something called DPO, or direct preference optimization. And essentially the goal of direct preference optimization is to align a language model. And what that basically means is that you have a language model and then you try and steer it in some way to be behaving more in a way that you desire. And for me, this doesn't help me that much. But what does help is the kind of data set that is actually represented or expresses this DPO algorithm. And essentially, what you end up having in terms of a data set is that you need to have some input column, which is the kind of prompt that you pass to a language model. And then you have a pair of responses, and one of those should be the kind of chosen pair. So that's the pair, the response that you want the language model to be more like, and then the rejected response, which is the one that you find less helpful. And the reason this is really nice as a kind of approach is that previously, when you were trying to do this language model alignment, it was often done through reinforcement learning with human feedback. And that would usually involve training a separate model to learn these preferences, and then you use that model to apply some kind of reward to the language model during training. But this DPO approach basically skips that step, and you can directly create a data set that expresses these preferences. And I think that's been really exciting for the community, because I think it allows for some more interesting ways to actually come up with approaches to create a data set that basically has one input and then 2 outputs, where one should be better than the other. So that's where we get to the process for creating this preference data set that has this initial prompt and then these 2 responses. And as you can imagine, there's different ways of going about this. I did have a bit of a look for haiku data sets that already existed, and I did find a few, but they were fairly small and weren't really what I was after. So as you can imagine, based on the kind of intro to the talk, the approach I took was to create synthetic data for both of those haiku responses. And basically what I wanted to be able to do is to have an input prompt and then these 2 responses that we saw in the previous slide. And in this case, all of these parts should ideally be generated synthetically, so I don't actually have to create all of the input or response data myself. So the next kind of part in creating this preference data set, where you have the input and then these 2 outputs, is actually deciding which of the outputs is preferable. And this is where there's been various different approaches that people have tried to use. But one thing that a lot of people are now starting to use is another large language model to judge the kind of potential responses and provide some kind of score. When I first heard about this, I found it really weird, and I still find it a little bit weird, but I guess accepted that this is something that people do and it can work quite well. But one of the problems for this particular topic is it's actually quite difficult, I found, to get a good rating for a haiku from a large language model. So I tried a few different approaches. So one was to directly rate the aesthetic quality of the haiku, but I found the responses were fairly noisy. And the other thing that I tried to do was actually to look at these stylistic properties. So this kind of 5-7-5 structure that a haiku should have. And actually, even GPT-4 doesn't do a very good job of this. It will often give you an answer, but then if you prompt it again, it will give a different answer. And it tends to be fairly inaccurate in actually scoring based on syllable counts. So this is where haiku again became quite interesting to me, because unlike a lot of text where it's quite difficult to actually write rules to say, okay, this text is better than this text, in the case of haiku, you do have some kind of structure that you can infer computationally fairly cheaply that actually gives you a sense of whether technically one haiku is better than another. And that's where distilabel comes in for this project. So for these first two steps, distilabel basically will help you generate these haiku prompts. So basically simulating a user saying, hey, LLM, write me a haiku about moss, or write me a haiku about forest. And then the next part is to generate multiple responses for each of these prompts. And then I think the bit that's probably slightly different in this project to how people often approach this is, instead of using a LLM to rank these outputs, we can actually define the responses in terms of Python code, and the ratings in terms of Python code, so we can score the responses directly in Python. And that's nice for a few reasons. One obvious one is that it's very cheap, both in terms of cost, but also computationally, to rank things using Python code, rather than having to use a fairly heavyweight LLM to try and do that ranking. So I'll show you quickly the notebooks that I use for some of this, but I thought just quickly I would talk about the next steps for this project before I do that. So at this point, what I've got to is basically the point in which I've created this DPO dataset, where the rankings are really based on the scores generated by the Python code. But what I also want to be able to try and do is to actually get back to this question of aesthetics. So instead of just saying this haiku is technically correct, I want to also be able to say this haiku is better than this haiku in some kind of vague aesthetic way. And I've made a start doing that in Argilla, but I have to say it's actually quite difficult annotation task. And I'm quite sure that when I label things twice, I'll probably give a different score every time. But that's something I'm continuing to work on, think about how to set that up as an annotation task. And the other thing, which I have no idea if it will work, but is to try and train a smaller text classification model to make those predictions for me. So once I've labeled some preferences for haikus, actually train a small model that can then do that part for me, and then generate a much larger data set without actually having to label all of those by hand. As I said, I don't know if that's going to work, but I think if it would work, it would be quite an interesting approach for many people who want to train an LLM for a very specific task, but don't have a lot of people to annotate, and might not be able to rely on a large LLM to do the rankings for them. And then the second goal, which is related to this topic, but also a little bit outside it, is to see how much I can get a very small LLM to actually get good at this very narrow task of writing good haiku. So I think increasingly people are using very large language models for many tasks, but I'm still quite excited about the idea of a 7 billion parameter model, or a 3 billion parameter model, or ideally a 1 billion parameter model, being able to do something which in a way is a fairly constrained task. It's not asking it to write code, it's not asking it to write recipes, it's just doing one thing. So I think that's a longer term project, but that's a second thing that I want to work on. Let me just share this tab. So I'm just going to talk very quickly through this notebook, and I think you can find it afterwards. David has the notebook, but I also have a GitHub repository where I'm sharing all of this work. And basically there's 3 different notebooks, so I thought I'd walk very quickly through 2 of them. And there's 3 main parts. So there's the generating the initial request for haiku part. There's generating the response part, which actually, thanks to distilabel, is really like a couple of lines of code. And then the third part, which is creating the actual preference rankings, which I think in this case is probably slightly different to how you'd normally do it, but I think is an approach that probably could be adopted for other use cases as well. So yeah, as I mentioned, I'm using distilabel for all of this. So just make it a bit bigger. So yeah, distilabel, if you haven't come across it before, it's this really nice library from Argilla. And the idea is that you can use it to generate synthetic data, and particularly to generate synthetic data for this alignment process that I've been talking about. And there's some really nice kind of building blocks that allow you to do that fairly easily. But the part that I use most heavily in this notebook, which I will focus on, is the part of generating these seed prompts. So there's different approaches that I tried out with this. The first was actually to do something very rules-based, where I basically just had a few sentences and then, replaced a placeholder part. So we'd do something like generate a haiku about blah, and then insert different words for blah. But I thought that would end up being a bit suboptimal, because you'd end up with very kind of rote prompts. And if you actually wanted to use this in some serious way, it's probably not going to be very robust as a training data set. So this is where I built on this approach mentioned in this paper called self-instruct, where they have this very nice approach for generating instructions or prompts automatically, and basically doing that from a bunch of C topics. And the way I worked out how to do this is basically copying and pasting one of the tutorials in the distilabel library. And then when I first did this, I had to hack a little bit in the library to change something, which has now been updated, so it works out the box in a very nice way. So you can see here a bunch of words, and these are all words generated by GPT-4. And basically what I asked for is lists of animals, and then kind of vibes-based things, so like a bamboo in the wind. And basically I was trying to get at the kind of things that might be spoken about in traditional haikus, which are often about nature, but then also have these very kind of abstract topics, which again I thought would be interesting in terms of generating a data set that was quite rich in terms of the responses and the prompts that you give. So seeing how well an LLM can respond to these fairly abstract prompts for generating haiku poetry. And then, because I thought that the types of people that might ever play with this model are likely to be people with a kind of technical interest, I thought I would put in some technical terms just to see what kind of haikus might come from that. They're probably slightly less beautiful, but yeah, maybe they're also interesting. So anyway, basically from those seed terms, it generate a data set which has a bunch of these haiku topics. And then that's where you can start using this self-instruct approach. And essentially what this self-instruct is doing is creating a prompt to a language model and doing it in a way where it will try and generate new prompts for you. And I actually found trying to generate prompts can be quite tricky. So synthetically generating new prompts can often be quite confusing for a language model. So if you say, could you create a prompt for a user requesting this thing, it will often just respond to the thing that you're asking it to write a prompt for. And I think that's one of the reasons that having these kind of templates can be very helpful, because you avoid some of that headache, because you start with something that's already been shown to work quite well. And the approach that this self-instruct paper takes is basically that you have this application description. And the goal with that is to describe the end application that you will be building. So in a way, it's starting backwards and saying, okay, this is who you would be prompting. And the other bit that is quite important, and the bit that I had to hack to change, is this criteria for the queries. And this is, again, helping the LLM know what kind of prompts it should generate. And there was one part in this last line here, which is saying blend interrogative and imperative styles. And in the case of haiku, that really the generations, because they would often then be like, how do you write a haiku? Or it would just not have the kind of prompts that I wanted to. Basically, getting rid of that part of the generation query already helps a lot with the prompt. And from that part, you basically have all of the building blocks you need for this self-instruct task, which is one of the kind of templates that distilabel provides you for generating this data. The only other thing that you add here is this system prompt, which just helps the prompt be a little bit clearer in what it's doing. And then there's quite a lot of explanation here, but the kind of summary is that, as I mentioned, distilabel makes it very easy to use a bunch of different LLMs, so both open and closed. And often then, if you want to switch out one, then it's just a few lines of code that you need to change and everything else will work the same. In this case, I used a fairly small 7 billion parameter model that I found worked quite well for this via the VLM library. So this will comfortably run in a Colab notebook and is pretty fast, so it can be a quite nice way of prototyping. And I'm not going to go through all of this code in detail, but basically once you have this task and the data set with our initial C terms, it's fairly straightforward to just generate all of these prompts. And you can see that it goes through a bunch of batches, and then you end up with this initial data set of prompts. You could make much bigger by changing the number of generations and the number of data inputs. And that's the kind of part for generating this initial prompt data set. So as I mentioned, I was going to skip over the next part, which is then responding to those prompts and returning the generations. I think all I would say about that part is that all you probably would want to change in compared to the approach I took is to have a lot more responses from different large language models. So the approach I took to keep things efficient was just to use one. But I think ideally you would use a bunch of different language models and then rate all of those separately. But that's something I'm starting to work on a little bit now. So this notebook goes through what to do once you have this initial input prompt and then these different responses from the model. And then I guess this is the point that I return to, where the normal approach is to use a large language model to do the ranking. What we do here instead is to try and define some of these rules. And I won't go through this in a huge amount of detail, but there's some quite simple rules that I ended up coming up with here to score whether a particular haiku was better or not. So you can see here, this is the data set that I generate in the previous notebook, where for each data point to each prompt, you have all of these different generations. And what I want to be able to do is say, okay, this one is better than this one, or this one is better than this one. And that's basically what the rest of this notebook tries to do. So the first thing I checked for is whether it's 3 lines. So that's quite a simple thing to check in Python, but that already returns some responses where the model hasn't returned the right number of values. So that's something that already you can say, if it doesn't return 3 lines, let's score that quite low, because that's failing to do one of the basic things that you would expect in a haiku. And the next part, which is slightly more tricky and doesn't work perfectly, is to then try and score the syllable. So I'm not going to go through all of this in great detail, but basically use some existing Python libraries from the kind of more traditional NLP world to count the syllables for each word, and then to basically count the syllables on each line. And then here I define some fairly arbitrary scores. So if all the counts are correct, then it gets a score of 4, and then it goes down. And basically what I wanted to do is have this kind of ranking from a scale of 1 to 4, and I think the scale could be changed in different ways. And then because under the hood, what you get back is this Hugging Face data set, it's quite easy to apply this scoring across the whole data set. And then the kind of only next step then is to work out which is the chosen out of the generations and which is the rejected. And again, that's something where I think you could play around a lot with, but at the moment, what I've done is basically for each example, taken the worst scoring response as the rejected one and the best scoring one as the chosen response. I think there are like other ways in which you could try and do that scoring, which would be quite interesting. And I think in general, this could be an interesting approach. This is very specific to haiku. But I think particularly for things like code generation, there's already other ways in which you could say this piece of code, for example, is better than this other piece of code without having to rely on a large language model. So I think there are some quite interesting opportunities for building very interesting data sets that don't just rely on using a bunch of GPT-4 credits to do all of the scorings, but could instead leverage existing kind of libraries or existing approaches to provide those scores. So I think I've run out of time a little bit, but yeah, very happy to take questions. And as I said, this is a kind of work in progress, but I am sharing all of the things I'm finding on GitHub, and all the data sets and models will be on the Hugging Face Hub.
Yeah, thanks a lot for the presentation. It was cool to see how you actually came up with the idea and what the follow-up steps are. There are some questions from the audience. Yeah, for me, like you mentioned that you initially started with the idea to create this so-called sci-fi data set. And how did you eventually end up with haikus? Because you skipped over that. Just curious.
Yeah, I guess I slightly worked backwards. So one thing that I found was, even in terms of doing the annotation, if you generate a paragraph of text for a sci-fi description, it's quite a lot to look at. And I knew that this was a project I was going to be doing on my own. So actually having a very short 3 sentence thing to run seemed to make sense. And then I think I also at some point caught on to this idea of being able to use rules to do the ranking, and I thought that would be interesting. I guess that's the other nice feature. And I have had some people tell me like this is not at all like how haiku actually work, and I freely admit that I'm definitely not an expert in haiku, but I think it's a nice kind of artificial rule at least to use for this task.
Okay, thanks. Then there was another question for me. It's not related to the haiku part, but about the data set cleaning part. Do you experience any issues with duplicate data sets? Because what I've seen, for example, all of these fundamental research data set, everyone kind of copies paste them to their own organization and then claims the ownership for on these topics. And how do you deal with that? And if not, why not?
Yeah, so I think there's something people are asking more and more about, and I think there's two parts. I think there's the part where it's some of the data is contaminated in a way, and I think there are various ways in which people try and do that. I think it's a little bit of hesitancy about really getting stuck into people's data sets too much, because in a way we also want to be a platform that's slightly neutral. But I think one area that I'm quite interested in is with models, we've added this idea of a base model. So you can express that one model was fine-tuned from another, and you actually start to see now quite interesting lineages of 3 or 4 generations of model, and you can see all of the steps in between. And I think particularly as people might start doing more work on cleaning data sets, then I think we might want to start adding more metadata about that. So for example, the data sets that Argilla have cleaned up to be able to say, okay, this is derived from this other data set, but it's been changed in some way. And then I think that could be quite a nice way of also allowing people to move to the cleaner version through the existing one. But I think there's some ways in which we can do that, but as always, it's like getting people to add that information or knowing that we can add it automatically quite easily, which is the tricky part.
Okay, thanks. Then the question from Krishna is DPO primarily designed to make models align with particular aesthetics, or can it also grow the model's knowledge? I believe that there's no like uniform understanding of where the knowledge is, so to say, in LLMs. But I believe that during the pre-training phase, the model actually learns the knowledge. Then during the SFT phase, the structure in which the knowledge is passed, and then during the final DPO phase, really more the preference alignment. But yeah, as it's not, it's more of a educated guess than actually knowing where each one of these phases turn out.
Mm-hmm. Yeah, that's my sense too. And I think, yeah, probably it's usually not used for aesthetics. It's usually used for some other quality metric. So is the response useful, or is it like very verbose or too short, that kind of thing?
Yeah, then for me, there was this. I'm not sure if you've seen this data paper introduced this prompt template evil quality, where you might be able to, yeah, seed your synthetic data generation in order to improve the quality through evolution. And you actually provide the prompt and the response pair that's actually validated and correct to an LLM, and then the LLM should improve it. So that might be an interesting way to actually, yeah, work towards already valid or well-known haikus that you have created already, and actually iterate on that a bit.
Yeah, that's on my to-do list for reading, and I saw that distilabel added some support for that. So yeah, I would like
Yeah,
to get to
yeah.
that.
Um, then have you explored any text quality style metrics like for example the text descriptors one? You briefly introduced I think this part about using this built-in package to look at the syllables and these kind of things, or this Python package, right?
Yeah, so that's what I've done so far, but I think getting back to this other approaches to ranking, I think this is where text quality metrics could be an interesting one. So you also have things like readability scores that you could imagine if you want an LLM that gives responses that are slightly more simple or easily to read, then you could actually use these kind of readability scores to rank them. So I think that's something that I personally think people should explore a little bit more, is not always using this massive model to do the ranking, but something slightly, yeah, smaller and maybe more nuanced in how it's doing the ranking.
Mhm. Yeah, this is, by the way, also something that we added as addition to distilabel. So after running your entire pipeline, there's this to Argilla method, and by default, you can actually get text descriptives and also vector embeddings attached to the text fields within your overview, and that will allow for way easier search and directly being able to navigate through your data instead of having to format everything yourself.
No, that sounds nice.
And then another question from Krishna, referring to the fact that GPT-4 is the best model to align with human preferences. I'm wondering if the OpenAI services don't allow using GPT-4 to improve other LLMs. Yeah, so I think that's also one of the things that nobody is still fully certain about, but everyone seems to be quite cautious about the usage of these models for training other models. But it's, yeah, a cat and mouse game where also I think GPT-4 and all of these closed source models were in the end trained on all of the data that we as mankind actually generated. So yeah, it's a bit of a vague and maybe also dangerous topic. So everyone is being cautious.
Yeah, and I think that there are other approaches to ranking coming out now. So this pair RM model, which is also much more lightweight, and I think that is hopefully at some point the community will get away from this GPT-4 dependence. I think that would be nice for many reasons. I also haven't seen a conclusive answer on this question. I think no one has said given the answer, or if they do, then yeah, maybe you shouldn't listen to them either. It's probably a question for lawyers.
Mhm. Then the last question, did you compare the GPT-4 results to other LLM providers? So you mentioned using ChatGPT, but maybe you also used, I don't know, Claude or some other models?
Yeah,
I
so
don't-
actually, I only used GPT-4 for the initial seed terms, so this kind of list of animals and topics that used to generate the prompts. So for everything else, I try to only use open models.
I think Ben has a question.
Yeah, thanks, David. Yeah, I asked that last question, and I actually meant, did you compare the rule-based
Mhm.
results to that of GPT-4 or
Hmm.
another LLM to see if the LLM could replicate the rules? I know it's quite a naive assessment, but it would be interesting.
Hmm. Not systematically. So I did try and play around with trying to get it to do something similar, but only in the chat interface rather than running that at scale. I think it could be interesting, and I guess it could be scalable if you had a bunch of different rules you wanted to do. But I think what I also quite liked is that the rules ranking I could do on a laptop basically because it's just very simple Python code. But in general, with GPT-4, I found it was like not very reliable at doing the syllable counting, it was quite, I guess quite noisy in its responses. So it would very confidently say, which is surprising to me, but maybe it shouldn't be. I don't know.
Okay, thanks.
Thanks.
Then I have another brief notebook that I can go over, and it basically goes over the Data is Better Together community effort that we've launched together with Hugging Face, and that Daniel van Strien has also been leading from their side, and actually goes over what happens if you have a data set from Argilla, how to analyze that based on the responses that everyone provided, how to look at these responses from a point of view as the number of responses per annotator, and these kind of things. And then eventually goes forward with that part to actually create this preference data set with also LLM pools or different kinds of LLMs and these kind of things. And this preference data set you can then later on actually use for, for example, fine-tuning an LLM through DPO. This is actually the notebook. I will also share my the URL. Then for the notebook, so what we've done recently is launched this prompt collective where we asked everyone on the Hugging Face app to actually log in to Hugging Face space. You can see that one here, and it's quite a easy press and integration. And then you'll end up with this data set where you actually have this prompt, and we asked everyone to rate these prompts based on the quality and based on the guidelines that we set. So we also provided an overview of how people should actually rate and consider these prompts. This is how we started. And after that, we actually released this data set from the prompt collective with 10K annotated prompts from different sources like UltraChat, but also synthetically, but also human generated data and also other synthetically generated data sets. And that's actually the data set that you can find here. Then what we did, what I will show is actually installing Argilla together with OpenAI and Seaborn and the datasets package. Next, we will import some of the required things. Then also set the OpenAI API key through actually this user data kind of environment variable setting thingy that we got from Google Colab. And that's actually a thing that you can add secrets here, which is pretty cool. Then we will be loading the dataset from the Hugging Face Hub. It's actually this dataset I showed you guys before. And this dataset contains the prompt, the quality. So this is the 1 to 5 rating that everyone was supposed to give, and some external metadata that actually contains some information about the source of the dataset and some other things. So this code, for example, unifies the responses. So for each one of the questions, there can be, for each one of the prompts, there can be multiple rating responses. And what we've done is just take a basic average of these ratings whenever there are multiple ones. We also compute the total number of respondents per rating, and we check for the agreement ratio. And based on these metrics, we can already get an understanding of how well your annotators are aligned during such an annotation process. And for example, you would also be able to mix in maybe some synthetic annotations from any arbitrary LLM that you would be using, or just rely on human annotations. And that looks like this. So you have your prompts in your data set. Then this would be an example of these responses. But then eventually what we end up with is the average rating, the number of responses, and the agreement ratio. So in this case, both of the users provided a 5 as a response. So it is a valuable high quality prompt. And when we actually use this map function from the datasets library to map everything and to the function and actually get the processed results for all of your entries. Then for some additional cleaning, we remove some columns and we actually convert the JSON metadata to a dictionary, and then get also the kind. So if it's either human or synthetic data, and also the source. So the main data set that we actually use to source the initial prompts from. Then the data can also be converted to a pandas data frame, which kind of looks like this. A cool thing that I found out is that, yeah, whenever you use Google Colab and Seaborn in combination, you can actually have these recommended plot function, and then you don't really need to think about visualization code, but then based on apparently the pandas format and maybe some LLM in the background, you can actually press one of these plots, and then it will automatically end up generating the code and showing this visualization. I thought it was cool. I didn't see it before, so wanted to briefly share with you guys. Next, what I do is actually get the number of contributions per user. So we'll actually loop through each one of the data sets, get the user ID for the response, and then get this long list of IDs. And basically on these IDs, we can actually make a visualization. As you see here, there were a lot of users that made a few notations, and then some people like Daniel van Strien also, and Danny from our side also did a lot of annotations, and then also some cool community members actually contributed a lot as well, which was nice to see. Then the number of responses per data point. This is also an interesting feature where you might want to see how many responses you have to ensure that there's enough responses per individual question that you've had, because one response isn't really a unified response, so to say. So you want to have some consistency among different users, among different models, among different responses to actually know that there's one consolidated outcome of everything. We can actually see something like the average rating as well, where the average rating is between 4 and 5. Or what we would also be able to do is, for example, check whether the agreement ratio, so that everyone agrees within the different responses, and actually ensure that there are multiple responses to see what would be the average rating then. And as we can see, it's roughly 4, which is nice because it aligns with the rest of the responses as well. And what we can see as well is that the synthetic data, the average rating for the synthetic data is a lot higher than for the human data, and also a lot higher than for the unknown, which might be a mix between human and synthetic data. So that's an interesting finding, that humans actually seem to prefer the synthetic data over human generated prompts. And this is another visualization of that outcome. And eventually, I also created like an overview of the average rating for each one of the data sets that we've used. And this is something that might be interesting for people to go over and to skim through themselves. Then eventually, as mentioned, there's this way to create this preference data set. Daniel also briefly highlighted this within his talk. So for this approach, we actually plan to create a synthetic data set, maybe do some DPO fine-tuning and other methods to actually create a model out of the outcomes of this initial prompt collective initiative. And the way that we would start something like this is, for example, by pre-filtering the data sets to filter out everything with an average rating of 4 or higher, and with 1 or more responses, so that we actually know that there's a uniform agreement on the fact that it's actually a better or high quality prompt. Then we would end up with something like rows or 1800 prompts, which could be good enough for a DPO fine tune. For this example, I will just filter out the 10 first prompts. But when you actually start generating a preference data set with distilabel, you can actually keep more than 10 whenever you actually want to do a full one. But for cost purposes and for example purposes, I'm limiting that now. Then we actually map this to a datasets dataset, which is the main source of the main source that we actually use for distilabel, the main class. And we will use a OpenAI generator to actually generate responses for this. And we'll do this through a text generation task with a distribution that we chose randomly now, based on harmfulness, helpfulness, truthfulness, honesty, and verbalized calibration. And these are some metrics that you can pass to the text generation along with the prompt to keep in mind while generating a response. On top of that, we will also be using a LLM pool, and this is actually a mix between different LLMs to ensure that each one of the LLMs is able to generate a more diverse output of the more diverse response. And we actually use this to avoid bias creeping into the generated data to the synthetic data. So for now, we're just using OpenAI LLM, but what we can also do is, for example, mix in Mistral or mix in, any scale endpoints or Claude or any other LLM that you might be able to use to ensure that there's less bias and the output is even more diverse, so to say. Then on top of that, we'll also be defining a labeler, which is in this case GPT-4, and we'll be labeling through the Ultra feedback task, which is one of these validated prompt templates that we've added as main task to distilabel as well. And as mentioned, GPT-4 is basically the only one that we can use because it's the one model that is the best in terms of alignment with human judgment. But I'm curious to see if Mistral actually also aligns with human judgments as well to the new large model that was released. And then what we do is actually set up a pipeline with this LLM pool that will randomly grab an LLM from the pool to generate a response, and then the preference labeler that we've defined. And we'll actually generate 2 responses per input prompt, and we'll forward this initial data set that we had with a batch size of 16. So we kind of pipe through everything quite quickly. This, for example, ran in 40 seconds, so that's not that long, but whenever you're creating thousands and thousands of responses, it might take a bit longer. Then, as mentioned, there's this push to Argilla method where we initially connect to our Argilla instance, which I've deployed already on Hugging Face Spaces for free. Then we will call this to Argilla. And actually, under the hood, this to Argilla method uses the text descriptives extractor and the sentence transformer extractor. And these 2 tools actually directly add vectors and metadata to each one of our entries so that we can search quite easily towards them. And then after generation, you can actually push your preference data set to Argilla to do further analysis with that. And within, let's see, and that would be this example. So then eventually you'll end up with this initial input, the generated responses, 1 and 2, and you'll have some sorting mechanisms, some filters, and these filters they actually contain these text descriptives, metrics for perplexity, number of sentences, entropy, and a lot of these other things by default, which you might be able to use as filters. Some other interesting filters might also be the distance best rating. So in this case, if the distance is higher, you would expect that there's a bigger preference difference. And in this case, then you might be able to filter out more relevant examples based on that. Another interesting thing is also this find similar function where you might be able to do vector search based on similar input examples. For now, it's only with 10 examples, so it's not really relevant. But whenever you have hundreds and hundreds of examples, it might be more relevant. So that's the brief overview of the outcome of DRBT and the prompt collective. Examples. Have we used Mixtral for preference generation yet? I'm not entirely sure if we've done that. Maybe Ben just joined, so maybe he doesn't know either. But maybe Danny or I feel free to ask in the community channel for our Slack. Then we will get back to you regarding that. Secrets in Google Colab. Do you know if putting any Hugging Face token in secrets allows you to access models? No, it doesn't allow you to. It doesn't automatically allow you to get access, but you would need to get this secrets from Colab and actually assign it to an environment variable, and then you would be able to directly do that. Or you can also pass this token then directly from whenever you're using a model or a dataset, and then it should work. In terms of datasets, have we looked at Langsmith? Maybe I need some more context for this.
LangChain has a tool called Langsmith that captures the overall dialogue flow for interactions. It's an audit trail, and I think that it's like real-time interactions capturing sort of data from using an LLM. So I think it's a perfect source, but may not be where you're focusing on.
No, yeah, we have looked at similar workflows or being able to capture similar workflows using Argilla, for example, Llama index chains or
Yeah.
DeepSet pipelines. But we
Yeah,
haven't looked at.
it would be very similar to Llama Index and their ability to capture the responses. Because one of the things that I've found is that the behavior of LLMs changes significantly across upgrades, etc. Yeah, I think that having that sort of training data based on real use is helpful.
Yeah, yeah. So we've had these two things, and basically you can configure Argilla in such a way that it's fully adaptable to whatever pipeline you want to capture. And the idea of integrations these, for example, with Llama Index or Haystack, is to really simplify the configuration for these kind of things. A thing that we do want to add is, for example, having this conversation structure based on OpenAI messages payload, so that you actually get this automatic out-of-the-box visualization more in a form of a chat format to facilitate that a bit better. But it doesn't cover like the full chain of calling different LLMs and tools and agents and maybe models in between. So that's where Argilla is a bit limited in that sense, but we do have more query capabilities and semantic search and these kind of things.
Thank you very much. Excellent session.
Cool. Yeah, and there's also a session about prompt engineering coming up if you're interested, and that will also cover probably the more chain focused approaches and change of LLMs. But if there are no further questions, then I would like to thank Daniel for coming by. It was really cool to see the haiku-dpo man in action. And we'll probably be chatting a lot on Slack and LinkedIn and wherever. And hope to see you, the rest of you, also for the next sessions.
Thanks a lot.
Thank you.
Thank you.
Bye bye.
Thanks.